So first thing to do is to connect the power to the Arduino and to the rest of the motor shield and for the sensors. So if you want to come along here, you want to turn on the power supply. Make sure that it's reading approximately 23.6 volts. That's what the sensors have been calibrated at. You can see the amperage is essentially 0. And you're going to connect the negative, or the ground, and you can see that the lights for the motor shield come on, and you've got about 0.15 amps running, which means it's safe and it's not overloading itself. Never adjust this beyond what the Arduino can handle so you don't blow it. So now everything's connected. You can see that the USB cable for the Arduino is plugged in. The rest of everything is turned on. So now the next step is to go to the computer and load the program that's going to run it. So you want to come along. Right, you. Alright, so you're going to open up MATLAB. We wrote this in MATLAB 2012. Other versions, especially later versions, will work as well. The correct toolboxes. So open file, create the file that's on the Velovations M drive, and run the Arduino GUI2 M file. See it loads up, hit run, and then you can see how it's started up. Minimize some of these things so we can get a better picture of what's going on. So first thing to do, you need to connect to the Arduino. You can see that it's not connected. Right now if you try to run, nothing's going to work. You see you set the COM port there, connect to the Arduino. Now we might have to redo this. There we go. Alright, so now it's actually connecting. You can see it's got a little status bar. It usually takes about 10 seconds. So successfully connected. Set all your parameters for your wheel. They're already pre-input for us here, but if there's a new wheel, it's into diameter, rim width, number of spokes, and then this is just manually how many degrees you want to run. So you're going to run it in a forward direction, just a manual run. And you can see that the wheel's busy turning over there. Displacement sensors are busy measuring the radial and lateral displacement. That is being picked up over here on the computer screen. You can see the sensors, these scroll bars actually presenting what the sensors are doing. A lot of vibration in the system, we know that. We need to figure out a way to fix that one. Here's the actual disc, it's plotted as well. Might have to come in a little bit, I don't know how far it zooms in, but you can see it continue running a little bit longer. It's plotting it. At any time we want, we can stop it, immediately stops the motor, continue running it again. We could run in reverse. So if we wanted to go backwards, you can see the wheel is now rotating in that direction. But usually what you do at the beginning, so we're just going to clear the plot, start from fresh, and we're just going to do a tuning run. So you'd get the, let's make sure we're going forward. Get the guitar pick, in this case, right in front of the spoke. And then hit tune. If you want to come look over here, you can see you picked up the spike nicely, 748 Hertz. So now we have what our nominal, that was the spoke we measured, the nominal frequency. So there we go. Now we could get into position and actually do a full automatic run. Alright, so here we're gonna start the full run. So that's gonna run full 360 degrees. So you can see by this red mark, thought about it there, go full 360 degrees. Little pauses in the motor is when it does its Fourier transform with the sound data collected, and so that's why it seems to jump every now and again. but otherwise it very consistently does go 360 degrees if you just input the values. This is purely just based on what the wheel said. It said 622 and it goes exactly 360 degrees. So if you want to look over here, you can see all the spoke frequencies it got. It actually picked up a lot of them this time. 1, 2, 3, 4, 5, 6. It's only recording at one side, but they're dynamically being plotted here. You can see how many degrees the wheels has rotated out of the 360 and of what the lost spoke was found. And as you can see, the flags are more or less where they started at, and it's recorded all the data we need. So now if we wanted to go tune it, we could go to an individual place using manual run again and actually go and look at it and then see how our plots change. For example, it's evident